Hi, everybody.
Hello, how are you?
I'm fine, and you?
I'm good.
All right. Okay, it's about few minutes to 3. Do anyone have any problem with any part of the assignment? Amy, are you there?
Hello, yes, I can hear you.
Okay.
Yeah, I got some questions from other students regarding homework 2. Also part 3, but especially question 11 and 12. Can you maybe explain?
Wait. Let's go one by one. But I will guess we have to wait a bit for other people to come. Probably those you are asking for may not be around. So let's give ourselves a bit of 5 minutes or so and check if we have a lot. Now we are 4 in class. Do I even know? Can I share my screen? Is it possible? Let me see. Oh, I have to contact Prof. Cheryl for screen sharing. All right, so the numbers are increasing gradually. Welcome. I wish I could get the name, but I'm not confident in. I hate to miss names. Probably we might have to introduce ourselves. I think we haven't gotten the chance to do that, right? Would that help? Anybody saying anything?
Yes. My name
Okay.
is Isaac Chilizidama.
Okay.
I'm doing second year masters on University of Pretoria.
In agric economics, right?
No, not agri-economics. I'm doing rural development.
Rural development. Okay. All right. Have you done econometrics before?
No, not yet.
Okay. All right. Thank you.
I've done statistics, not econometrics.
Okay. And did you use any statistical software in your statistics?
Yes, I've used SPSS, but hey, that was some time ago.
Okay. All right. Thank you. Amy, tell us something.
Hello, my name is Amy Grinling. I am first year MSc Agricultural Economics. In my undergrad, I had some exposure to SAS and a little bit of Python coding, but I haven't done R yet. So yes, that's my background.
Okay. So you are a bit conversant with coding with Python.
Yes, but I can't remember everything.
Oh wow. Okay. Thank you. Any other person? To Yen Nguyen.
Hi,
Tell us.
yeah,
Yeah. Hello.
I'm Duyen and I'm an exchange student from Ghent University, Belgium.
Okay.
Yeah, I'm studying rural development in Ghent
Okay.
University, and
Okay.
I used to learn about R before, but just
Mm,
basic knowledge about R.
okay. All right. That's fine. Okay. But you haven't done any statistics or econometrics before.
Uh, I used to learn statistics before, some
Okay.
basics knowledge.
Okay. All right. All right. Thank you very much, Tuyen. Musibadi. I hope I got it right. Are you there? Musibadi Tihol.
Can you hear me?
Yeah, I can hear you. Give us a brief about you. You want to know who is who.
Yeah, I wanted you to spell my name actually.
In fact, kindly help us with your name.
Yes, my name Musibiad.
Musibiad. Okay.
Yes, but I prefer Musa for sure.
You prefer what?
Well, Musa for sure.
Musa. Okay. Okay. All right.
Yeah, I've done statistics and econometrics at undergraduate
Okay.
level, but then with so much gap between studies, I just had to do this course at master's level in order for me
Okay.
to continue my studies.
All right. All right. Okay. So are you conversant with any statistical software like R or SPSS or whatever?
I've done Stata before, and
Okay.
on my old laptop, I think I have the model. So yeah.
Okay. All right. Thank you very much. Brian, please tell us something about you.
Hello.
Hi, Brian.
Yeah, my name is Brian Weiss.
Okay.
I'm also an exchange student from
Okay.
from Ghent.
From Ghent. Okay.
I'm also doing rural development.
Okay.
I also have basic knowledge. Are just the basics.
Okay.
Yeah, I also have basic knowledge in statistics.
Okay. All right. Thank you very much. Then Mabunda. Mabunda, please let's hear from you.
Good afternoon, fellow classmates.
Hi.
Yeah, Seleng Mabunda. I'm currently studying towards, it's actually my second year, doing MSc Environmental Economics. So,
Okay.
yeah, what else do you want to know?
Do you have any idea about any statistical software? R, Stata, SPSS?
Yeah, actually, we were using in the second semester of last year during
Okay.
environmental evaluation. So yeah.
So you are good in R.
Yeah, I can't say that I'm good, but I've used it before.
Okay, so you've done econometrics too before.
Well, the last time I did econometrics, I'm probably the oldest in the class, was in 2016. So yeah,
Oh wow.
to my notes and
Okay.
stuff. So yeah,
All
that
right.
was quite a
All
long
right.
time.
All right. Thank you very much,
Okay.
Selene. Molulera. Molulera. Yeah. I think I had the name. Please tell us something about yourself. We want to do a brief introduction. This is a virtual thing and we have to make it a bit lively.
I'm studying MSc Economics.
Please, your name, mention it well.
Knowledge about R and data. Yeah. Okay, from you.
Hello, you are a bit faster. Please come slow, I beg. Are you there? Uh-oh.
Yes, I'm
Hello.
here.
Yeah, you went too fast. I didn't hear anything. So come again. Your name and yeah.
Hello, can you hear me?
Yes, I can hear you now.
You can hear me.
I can hear you. I can hear you.
Can you hear me?
I can hear you very well.
Oh, okay. Yeah, I said I'm studying MSc Agric Economics. I have a
Okay.
brief knowledge about R and STATA and SPSS. Yeah.
Oh, okay.
Yes.
Your name?
It's Modulela Paku.
Molulela. Okay. Molulela.
Yes.
Okay. Thank you. Thank you very much. Thank you.
Thank you.
Zwandili. Oh, yeah. I think Zwandili is the name. Please tell us something. We have 2 more to go and we are done.
Okay, my name is Zwandile Taimane. And I'm studying agricultural economics as well.
Okay.
Yeah, I enjoy econometrics. Like I like analytics. I like anything that has to do with analytics. Okay, in terms of R, I do have a knowledge in R. I have taken an online course in R, so I do believe I can do modeling.
Okay. All right. I think the class is increasing in size and we have to start something. We'll continue the introduction some other time. All right, so we kickstart with any problem with the assignment. Amy, you were mentioning something in homework 2. Kindly come again so I can look at it for you.
Yes, there was a few students that also asked me, and I'm also struggling with the same. So in homework 2, part 3, question 11 and 12.
Part 3, question 11 and 12. Question 11 and 12. Okay, I've seen it. All right. What's your problem? What exactly is your problem? You don't know what to do, how to go about it, or what? Or you
Yes,
tried it and
we do not know how to approach it.
oh, okay. All right. Is that all you have for from your side?
Yes, that's all.
You are talking about trivial 11 and trivial 12.
Yes.
Oh, okay. All right. I've seen your problem. Okay, to start with, okay, let me go through the whole assignment. Then let's see what we are expected to do. I'm starting with homework 1. Okay, so from homework 1, question 1, or Roman numeral I, says that we should just replicate whatever is in the notes. So if you go to unit 1, everything in question Roman numeral I is in the notes, unit 1. So I don't think anybody has a problem with homework 1, Roman numeral I. Then you come to homework, okay, Roman numeral II. There we are expected to create a table as we have in the I number, Roman numeral I. We are to replicate the same table using these figures. Yi is equal to 5, 3, 2, 1, and 0.2. And Si is equal to 1, 2, 3, 4, and 5. You are to just replicate everything that you know in homework 1I. Do the same thing with Roman numeral II. Don't leave anything out. So from 1 to 2 to 2.1, 2.5, 2.6, 2.8, 2.9, just do the same thing as you have it with the Roman numeral II with homework 1. Roman numeral III, the third table, you have 3 observations. You have Y, S1, and X2. That one is just taking a similar approach as the previous. So you are needed to compute the mean of y, the mean of x1, s2. Then as the formula is shown, the variance of y, the variance of s1, and the variance of s2. The problem here is that because in the C, there's a bar on the S1 and there's a bar on the S2, there's a bar on S1 and S2. Ignore the bars. The bars presume that we should be doing something like a mean, which is not suitable for such a case. So there's a problem, there's an error in putting the bars on top. So find the covariance of y and x1, then you find for y and s2, then you find for x1 and s2. Ignore the bars there and calculate it as a unit variable. Do same for the d and the e2, the same you do. When you have these covariance calculated from the table, you can just fix in or substitute into the formula, and you are done with assignment 1. That's homework 1. Let's come to homework 2. Homework 2, Roman numeral I. We are expected to derive and expand the forms. One is summation of I equal to 1 till the nth number into bracket si minus c. And this is very, very simple. So you need to just look at the brackets and you have to expand the brackets. Then you do summation when there's a constant, and you do summation when there's no constant. If you refer to the notes, unit 1, I think there are examples of such in there. And then number 2, you have to know something like it's called completion of squares. If you know completion of squares, just apply completion of squares and you are done. It's nothing so difficult. And the whole assignment here in assignment 2, homework 2, in fact, you need a bit of arithmetic, mathematical arithmetics, what to do with the numerator, what to do with the denominator. And when you substitute figures, sometimes some of them you have to do change of subject, simple change of subject. So it's just mathematical gymnastics, nothing really difficult about them. In the homework 2, II, you are expected to show that is the relation on the left side is equal to the one on the right side. And when you have settled on your answer, you just tell us it is true or it's false. But I told you earlier on that we should just use the table 1 in homework 1. The table that has 1, 2, 5, 6, 8, 13. And the summation is 42 and 15. Use that table because it's already expanded in the notes, and you also expand it for this assignment. So every variable you need in there has been created already. So to ease up your work, just use the same table to answer from II to, I think, III. Yes, you have to use the table to answer from the trivia. I think it ends at trivia 10. Trivia 10, you have to use the table to finish all of them. If the left-hand side is equal to the right-hand side, just tell us true or false. That's all we need. Then, when you come to III, it tells you to also prove. This time around, yeah, hello.
Prince.
Yeah.
I think your papers are too close to the microphone. They are making,
okay. So they are making noise.
sound.
Oh, okay. Sorry. Trivia, whatever. Assignment 2, number III. we are expected to prove. You know, in II, we were to say either it's true or false. Don't show any working. Just do it on your rough paper and tell us it's true or false. But in the 3, show us that what is on the left side is equal to what is on the right side. All right. So you do what do you call it? Stepwise. Yeah, step by step, and tell us that okay, what is on the left and what is on the right are the same. But you are using the same table 1 from homework 1. Homework 2. I've seen Celine, I've seen your message. I'll address it. Thank you. Then when you do the left and the right, show us your answer, either they are the same or not the same. With trivia 11 and trivia 12, I will help a bit so that you continue from there. What you see in equation 1 in trivia 11 is just application of basic mathematical thinking. You have a summation at the outside of a bracket, and the bracket is equal to the number 0. It means that what is on the left is equal to what is on the right. So you expand the bracket. All right, expand the bracket. The summation sign outside the bracket, multiply it through what is inside the bracket. Then you get a relation. The relation, there's a technicality there. Remember, there's a constant there. When you summon a constant, you should know that it's a bit different. So on the second one, equation 2, first multiply the bracket by x. Then you multiply whatever you get by the summation sign. So meaning that the summation has to also multiply through. Kindly give me 1 minute. I'm speaking to Professor to open access so I can share my screen. Hi, Prof. Yes, I need access to share my screen on the tutorial. All right, thank you. Yeah, thank you very much for waiting. So when you expand the brackets by multiplying through by x, then you multiply through by the summation. What you do is that, because they say you should make B and A the subjects, it's just a change of subject thing, change of subjects. Make sure you have A or B at the other side of the equation, so you can substitute one into the other and you get the answer. I think this is a bit simple. Trivia 12, the same approach. Multiply what is outside the bracket throughout the bracket. If you have x outside the bracket, multiply through, so that you have a summation of something minus something, 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 equal to 0. Then you also make sure you find A, B1, and B2. This is substitution and elimination thing. On trivia 11 and trivia 12, if anybody has something, let me know.
Sorry, Prince, can you just please help us with principles that would guide us when we calculate it? Because you see, with the second one, where you have to calculate maybe AP1, because I didn't have a problem with the first one to calculate A.
Please,
but
please
now with
mention the number, the question number, because the questions are plenty.
I'm talking about trivial 12, and then when we were supposed to calculate P1. Yeah.
Okay.
When we are supposed to calculate P1, then now we struggled in terms of the rules, because now you'd see in the equation the first, let's say, equation 2. There's no variance, there's no covariance. But now when you suppose your answer is supposed to have variances and covariance, but we don't know the rules per se, I wouldn't say we don't know. Maybe we have forgotten along the way. Yeah, can you just help us?
Oh, okay. So did you do trivial 11 to get the variance and the covariance?
Yeah, I did A, but then with B I didn't, because I was also struggling there to just get that covariance.
Okay. What is okay? I think I have to tell you something here. Let's see. Okay. Your answer will not arrive at covariance and variance exactly. Your answer will arrive at summation. Let me show you something. Yeah, your answer will arrive at summation of xy minus summation of y times summation of x. And that expression there is the covariance. Then all over, like if you want to find b in trivia 11, if you want to find b, your answer should be n summation xy minus summation y summation x all over n summation s squared minus summation s to bracket squared. That expression on the numerator side will give you the covariance of s and y, and the expression on the denominator will give you variance in s. So it's not explicit that your answer will be covariant variant, no, but the expression there is an interpretation of covariance. So I think that's where you have Zwandile, you have the confusion. Your answer will not show covariance or variance. Yeah.
Oh, okay, thanks. I'll try it then and see.
Yeah. So the summation will tell. Okay, let me repeat again. I'll do for 11, but for 12, you'll find it out, please. Answer for A in trivia 11. A will be equal to summation y over n minus beta multiplying summation xi over n. And you know summation y over n is the mean of y. That's why you have y bar. And you know summation x over n is the mean of s. That's why you have s bar. So that's the what do you call the relationship now. When you have these summations and you simplify, you get A is equal to y bar minus beta s bar. For B, you have to get n summation sy minus summation y times summation s on the numerator level. On the denominator side, you have to get n summation s squared minus summation s all squared, or squared outside the bracket. These two will give you variance, covariance, and the mean.
Sorry,
Thank you.
Sorry,
yes, Amy.
Possible that you can share your screen?
Okay, I can share my screen, but I don't have these things on. Probably I'll have to join with my phone so I can show you what okay, fine. Let me see. I think I can type these things on the screen.
Please, we'll appreciate that.
All right. Can anybody see my screen?
Yes, we can see it.
You can see?
Yes.
Okay. All right. So I go to Word, create any word. I can type for you to see. Okay, I can even open homework. That's homework 2, right? Yeah. A lot of things are running on my machine and it's getting slow. I hope it doesn't freeze though. Okay, okay. I think my word is ready. I hope this thing doesn't freeze. All right, homework 2. All right, we are here. Okay. So, I'm opening the math app so I can type there. Summation. Where has the summation sign gone to? Wow. Okay. For time's sake, let me use this sign as summation. All right. So you have summation. You have please, can you see?
Yes, we can see.
Okay, so
No, can you please at least increase the font because I cannot see properly.
All right. I'm increasing the font here. Okay, I hope it's okay now. So beta or small b is equal to summation. Let me use this pound sign as a summation for now. So you get small n summation xy minus the sign again. Okay, summation y summation x. Okay, all over. Okay. summation S squared, okay, n s power 2 minus summation x to bracket squared. Is something I want you to see. This is how the B is gonna look like after you have expanded the brackets and you summarize like this. So n summation xy minus summation y summation x is covariance. Okay, this here is the covariance, all right, of xy. Then the numerator here is x squared minus s squared, and it's just the variance of x. I hope you get it. Hi, anybody there?
Yes, on my
Yeah.
side, I'm still trying to calculate to see.
Yeah, so you expand the bracket with the s and expand the bracket alone with the summation. When you get the two equations, try to make beta the subject with the equation 1. No, make a small a the subject in equation 1. Then what do you call it? By elimination, you substitute it into equation 2, and you find beta. When you make a the subject in the equation 1, you are done with it. You get a is equal to summation of y minus beta summation of x all over n, and it will give you just the mean of y and the mean of x. So this for trivia 11 and for trivia 12, when you find these ones, you can continue with them and finish it up. So let me go back to okay, all right. So okay. So to the next one. When you get to IV says that let S and Y be a random variable and let C and D be constant, then show that. So here you can pick figures from table 1 and you use them in estimating or showing that the one equation on the left side is equal to the equation on the right side. For the V and the VI, VII, and VII, I think there's a problem with the numbering. VI appears twice. The second one should be II. So it's all about the formulas and substituting in the values. Yeah, I think I'm done through this one. So apart from the trivia 11 and trivia 12, if anybody has any question anywhere, then we can look at that. Kindly let me know if you have a question. Oh, I think because I lost the, I've seen a lot of chat coming here. Okay, Light is saying this one was fast for him. Okay, I think I shared the screen. So anybody has anything, let me know, please. This is virtual things, and if you don't take care, you are going faster than you think. Please say something.
One thing I would like you, if it's possible for you to share with us, is these math properties, if you have them, maybe if you can just share these properties so that at least they can just kind of like guide us, because we find ourselves in very strange position where you don't know like what property must you use to like kind of like arrive to the correct answer sometimes.
All right,
yeah,
so
if it's possible.
Yeah, I'm coming. Yeah, I'm sharing that with you. For homework 1, okay, I don't think there's any technicality there that is a problem. The formulas are there, you expand and you create the columns, you are fine. For 2, let me go over the 2 again. 2i, I said you expand the bracket with 2i, number 1. Summation of xi will multiply or minus summation of the constant c. But in this case, you have to expand. You have to expand the summation. The question says derive the expanded form. So just after you multiply the summation with what is inside the bracket, you expand accordingly. Expansion has, if you look at unit 1, there's expansion in there, and you expand it accordingly. Question 2. You don't multiply the summation right away. You first do completion of squares. That means there's a s1 minus c raised to the power 2. First, try to expand that bracket with the squared number before you multiply whatever is in there with the summation. So in board mass, always there's bracket first. You simplify the bracket with the squared. Then you multiply through the summation, then you expand accordingly. True or false? Use table 1. All the columns have been created already. Use it to prove that number 1 is true or false, number 2 is true or false, to number 5. I. Now you don't show true or false, but try to let us know that yes, what is on the left hand side is equal to what is on the right hand side. So you do a step-by-step thing and let us know what is there. You do so for question trivia 1 to trivia 9. Then trivia to trivia 10. Then trivia 11, I have gone through with you. Expand the bracket with what is outside the bracket. When there's an x, multiply the x through with what is in the bracket before you add the summation. Then you do a change of subjects. You make A the subject with equation 1. Then you substitute to equation 2. So you find A and B. But note, your answer will not result in covariance or variance. It will result in summations. Then your summations will tell straightforward that you have a variance covariance. Trivia 12 is similar to trivia 11. Expand the brackets, then simplify, make the subjects, then find alpha or A, B1, and B2. So after everything, your answers will result in beta 1 being covariance of this or that. Covariance will not come straight from your work. it will come in summations of X and Y and summations of X's alone to show you that you are either doing, you have a variance there or you have a covariance. When you have X and Y summations, then it's a covariance thing. When you have X only, then you are looking at a variance of X.
Okay, Prince, can I just ask with regards to trivial 3 and 4 there? Okay. They're supposed to like show that, because I just want to know if I'm in the right path.
Okay.
I'm supposed to prove that because it's at least how many sums? It's like 3. It's
there
4.
are 4.
I mean, actually,
four
it's
sums.
4.
Yeah.
I'm supposed to prove that all, because what I find, I can prove that maybe the first one can be equal to the last one, but these, the ones that are maybe in between, maybe they would be missing in my calculations. Or are we supposed to have all of them, or this is guiding us to say maybe we should know these to go to the last one, or what?
Yeah, Zwadili, the only thing here you have to do is to create the columns in the table. Surely, if you have a summation of X minus S bar in your table, the square of it, the summation of the square is only one variable, it's only one figure. It doesn't even vary, it's one figure you get. So when you have summation of S minus S bar squared, it's one figure, let's say 12. Then you come to summation of S minus S bar alone, multiplying X. If you have them in your columns, you sum all of them, you also have one figure, let's say 12 or 13. So it will prove to you that, okay, 12 is either equal to or not equal to 13. The 3 of them, the formula looks big, but when you have your columns in the table, it's a summation. I hope you understand.
Yeah, I do understand.
It's a summation thing. Just sum them up and compare. Simple. All right, thank you for getting it. So, yeah, I think with what is happening now here, the VII is the same error calculations, and I think they are similar to what we have in even assignment 1 or homework 1. They are almost the same there. Anybody with any other questions? Can we move on to another thing? Please talk to me or type something.
Yes, thank you. We can move.
Okay. Any seconder? Any seconder, please. Light, can we move? Okay, I think.
Yeah, yes.
Okay.
We can.
Okay, all right, thank you. Today, my session was to help students get this thing, this assignment, and that'll be all. So I pleaded with Dr. Gaj to allow me the space to introduce this thing. You know, as MSc and MPhil students, our main aim is to conduct research one way or the other. And this econometrics we are studying will help us to make good and quality research work. But in our current world today, everything is computerized and we have skipped the manual systems. But I'm now today just taking us through a small bit of how to capture data, provided if you have any problem at your locality, your area, your office, wherever, and you need to gather data yourself. You may not be good in creating Google Forms or ODK softwares, but even when you are good at that, you need to plan your questionnaire to capture what exactly you need. In our subsequent studies next week, we are only going to deal with data imported into R and we work with it. So this thing we are doing today, if you don't get it today, probably you may not get it in this particular class. So let's just keep cool and go through this. Okay, so to start with, I sent two sample questionnaires to the WhatsApp group. I hope everybody has it by now. We are to compare these two questionnaires and see what exactly is in there. The two of them are questionnaires that we used in 2016 to do a comparative study between Ghana and South Africa. We were looking at financial knowledge among university students. So I just took the introductory part of the questionnaire so that we can go through. If you look at the two questionnaires, they are trying to capture the same information. They are trying to capture the same information, personal information about somebody. But look through sample 1 and sample 2 and tell me candidly, which one of the samples captures the information better? Between sample 1 and sample 2, which one captures the information better? Just a quick glance through. We are talking about students and we want to know something about them with reference to. Anybody with a contribution?
I think sample 2 is better because it's more compact, so people can answer it quicker and faster, and they understand what the questionnaire is asking better than the previous one.
Okay, so Amy says that sample 2 gives better understanding than sample 1, and it's faster to go through. Who again? Any view?
I think questionnaire 1, for me, I feel like questionnaire 1 is just straightforward. Like the information, it's more of you just have to choose under which category maybe you fall on. Like I feel like even though it's not comprehensive, but I think it would catch our information better.
So you think Zwadile thinks sample 1 is better for him. Jano Smith, are you there? What do you want to say? You have to say, Makana, tell me something. If you inspect the two questionnaires, what is happening there?
So questionnaire 1 is very broad and not very specific, but when you look at questionnaire number 2 or sample 2, it's much more specialized, ask a lot more detail. Yeah, I think I would go with sample 2.
Okay. Makana, you are the last person on this, then we move on. Tell me something. Are you there, Makana? All right. Alice, tell me something. Makana is not speaking. Are you there, Alice? Okay, Alice also. Then I'll go to Mercy. Mercy, what do you see? Hi. Probably they are connected, but they are not with us. Probably. I don't know though. Okay, so what is happening in sample 1 is that the questions are straightforward, as said by Smith, and they are not comprehensive. As a researcher, you will have to juggle between the time a person spent on a questionnaire and the information you will need for your research. But mind you, don't trade off the supporting facts for your research for time, because when the respondent has left you, you may not find him to answer any other question. And be mindful that you need resources and time to complete your research. So one of the ways to beat up time is to make your questionnaire simple, but you employ tables, as in sample 2. The tables in sample 2 capture very wide information and makes it simple for the respondents to choose from. Look at A6. Say which best describe your parents' current monthly income. You don't have to guess much. Just look at the numbers and tell us the range. You are good to go. So tables like this allow you to broaden your horizon in terms of research and capture much information. You need much information when you are discussing your results, because some of the variations or the things you find out in your work may be reasons that may come from the answers your respondents have given you. If you make it too simple, as in questionnaire 1, you may not know what exactly is influencing the decision of your respondents. So a question like A2, which of these best describe your permanent place of abode? Are you living in a village? Are you in a small town? Are you in a town? Are you in a city or a large city? This one may seem like useless to you in a questionnaire that is looking at financial knowledge. But when you run your regressions and you do your analysis, you realize that no, some of the factors, the variables, they are not responding as you want them to respond. Quickly, you can come back to your data and find out, okay, how many of my respondents were in a village? How many were in a city? And how many were in a small town? This will inform you why some of your variables are not responding the way it is. If somebody is from a village, you realize that access to banking systems and financial knowledge will be very limited compared to somebody in a large city. I hope I'm making some sense.
Yeah, you absolutely does, man. Yeah, it makes sense.
Okay. So when you're creating or you're capturing data on any level, make sure you are compensating for time, but you are also very much aware that you need some variables to explain your models. If you read published papers, you realize that the econometric estimation there doesn't make anything. It's about the reasons behind why their variables are so. Everybody knows that inflation has a negative relationship with GDP. But you, in your research, you find out that the equation is not so. the relationship is not negative, then you panic. Then my work cannot be accepted. But when you go back to your data and you look at it carefully, look at all the variables you captured, then you realize that, okay, these particular people from this side, these were their characteristics. This were how they answered the question based on where they are from. Okay, let me take them aside and look at it. You take them aside and you know that the thing has come to normal. So in your inferences, you can write that people from location A or B are having these characteristics because of this, that, and that. Your result may not be the same as theory, but it may be backed by some of the variables you have in there. All right, so these are the two things I want you to look at. Time, compensating time for key variables, because when you go to the field for data, you may not go again. Currently, we have a lot, like South African system, have a lot of secondary data. Companies and government statistical services have data that they make available for researchers. But some of the secondary data that you take, you may also have to go back to where the data was taken from to find reasons, because some regressions, you run them, you cannot explain. Anybody that has worked with data before in an office or an internship, you run the thing, but you can't explain anything there. So sometimes secondary data is good, but if you have secondary data that you cannot explain, it's almost useless. All right. After we've done this, we now go into how we can really capture data into any software. With R is different for someone to capture data into R. Let's say you have about 20,000 or 10,000 respondents or variables to look at. In R, it's very difficult to put in data. The most common one everybody knows for data is Excel. Excel is the oldest and the widely used spreadsheet you can have. But for me, the most simple and efficient data capturing system when it comes to primary data collection is SPSS. I'll show you that briefly. Stata 2 can allow you spreadsheets that you can enter data. So Excel, Stata, and SPSS, they all allow you to enter data, but all of them has their way of manipulating the data. Let's start with Excel. I'm just showing you an Excel file. Okay, no, let's start with SPSS first, then we come to all right. So SPSS is like this. The data that you have, the questionnaire that you have, this is how we enter it when you have it on a sheet of paper. Probably you are doing some survey with your office or your class or something, like 20 or 30 people. You have put the questionnaire as you have it in front of you. Sample 2 is what we have here. So if you come here, you have data view. This is data view. Every question that is there has column in which it is placed. Look at the questionnaire you have, and you see that the questionnaire ID is there, the numerator ID is there, the gender, the place of abode, age, study field, study years, all these things. This is what we call a template. This thing is a template. It has no data inside. So you can give this template to anybody else to enter into its data from this questionnaire that you have. How do you create this template? You look to the left, down left corner, you see data view. That's what we are looking now. Now you click the other side, you know it's variable view. What makes SPSS the best is that you can switch between variables. If you do research, you realize that the way your variables are arranged is also very important. So let's say you want to switch gender to come to number 4. Gender comes, place of birth can go back to number 3. This is the feature of SPSS that makes it the best among all data entries. If you want to enter data, you can switch any number of the variable. Okay, let's go and see. If you switch place of birth to come to number 4, let's go to data view and see what is happening. Place of birth has now come to number 3, gender is number 4. Place of birth is number 3, gender is number 4. You can see here. Let's go back. You change it back. Now let's go and see if gender is still number 3. So now place of birth is number 3, and now it has changed again. So this is a feature of SPSS that makes it very, very easy. When you have data like this, you can create all the columns you see there. They are number 1 to this 25. You just put them there. You can create a label and say that questionnaire ID. Okay, you can say age of respondent. You can just type age of respondent here. And this one will go with the data anywhere you go, you send it to. You have this label is trying to say something small about the variable here. So if you have secondary data and they don't have labels, it becomes very difficult for you to explain them. So as a researcher, whenever you create data, you just have to give them meaning or labels. So here is let's say faculty. Yeah, you can put faculty there because the field of study. How many years? Okay, years in school, years spent in school, and that's all. So this is how you create labels. And sometimes too, you have a yes or no answer. Yes or no answer, you come here, you click here, and you say 1 is equal to yes. Then you add. Then you say 0 is equal to no. Then you click OK. So now for questionnaire ID, you can go and say yes or no. So when you go back here, questionnaire ID, when you put in number 1, it will give you either yes or no. I hope you are following. Hello.
Yes.
Yeah, okay. So this is how you create variables, and we have variable or value labels, and we have values. This is value labels, label them, and this is values. We have the same thing in Stata too. I'll show you how Stata works. But if you want to have any form of data, basically you can also change if you want numeric or string. Probably your answer or your data you are entering into this one is not numbers. It may be something like strings, like a sentence. You can go and choose strings, and you can type any sentence in there. All right. And when you want to type sentences, you have to increase this number, the width, because it means that you can only type like 8 characters there. When you increase it, you can increase it to any number at all to accommodate your sentence. This is the width. All right. Okay, so a brief of SPSS, how data is captured inside here. When you finish your data, you can export the data to any database. This is what is very important. You can export your data, and you can export it to any other database. Better still, you can go to save as. SPSS has the widest save type in all statistical softwares. You can save in SPSS, you can save in phase Excel, you can save whatever you have in Excel, you can save in DBase, DBase2. You can save in SAS. You can save in Stata version. You can save your data in any other form with SPSS. These two things make SPSS very, very simple to use when you have an office job or something to do. All right, so you save your data, and you can, if you save it in SPSS, you can save it in Excel, you open it in Excel, you can save it in Stata, you open it in Stata, and that will be fine with you. All right.
I'm sorry to interrupt you, Prince.
Okay.
Because with R, a data is given an object name. Maybe you say A is equal to maybe data. You specify your data. Can you still save something from here to R, or would you need to save it in Excel first before you can go to R?
Yeah, you can save in R when you want to. Next week we'll be doing R, don't worry. In R, when you want to import, it will give you many. If you want to call what do you call it, a data in R, you can call it with .csv or .csv2. It depends on how you save the data. Okay, so we will call some data in R, and we see the extension that we put there. If you put the wrong extension, the data will not even come in the first place. All right, so you can save. Let me show. Okay, this is the questionnaire that you are having. This is how it was entered. Okay, so gender, 1 will be male, 2 will be female. Place of birth, the what do you call it, the options that are there. Look at the questionnaire, the options that are there. You number the options 1 to 5. So if it is a small town, it has a number. If it is a big a city, it has a number. The ages are absolute as the respondents give. The field of study, it may be Greek economics, it may be whatever. Then study years, it's between 1 and 4 because it was undergraduate, so 1 and 4 years. Then parent income, the ranges were there. Every range has a number. So when you do all these things, then okay, let me change the values for gender, and let's say 1 is for variable view. So gender is here. We go to the values and say that okay, 1 is male. Then we add. Then we say 2 is for female. Okay, then we add. Then we press OK. We now go back to data view, and everything has changed. So all the 1s are male, all the 2s are female. It's as easy and simple as that. So that is what the data values do. When you have a data, you go to the values, then you change it this way, and it is done. So from here, you can run any analysis that you want. In Stata, in SPSS, they have this place called Analyze. This is where you have all your analysis, descriptives, the tables, the means, everything is here. All the regressions are all in Analyze. Okay, so I'm just introducing you to how to save data. So today we are not going much into all these things. All right, so the next place we go is Stata. All right, so my Stata is rough. Okay, fine. I think I have something here. All right, so like the variable, the data that we are using for question 2. If you have data like this, you can always add. If you add 8, it will add. If you add Stata, okay. I think I used browse instead of edits. Fine. You have variable 1. Stata is a bit different. It has all its variable properties at one side, unlike SPSS. So you go here, you go variable name on your right side here. You go there and say y let's say y-axis. Y is just simple. Let's say y-axis. Okay. Then you have the label. Let's say this thing is disturbing me today. Let me go and open a new one. Okay, but once you create, let me open a new stata before this one disgraces me here today. Okay, stata. All right, I'm opening a new stata so I can work with stata briefly so you can see. All right, a new stata is in. Okay, stata is like this. You have these two square boxes. This one is data editor and this one is data browse. When you click the one with the magnifying glass, you cannot do anything with the data. You just look at it, you observe it. When you click the one with the data editor, you can edit your data. So if you want to put data into stata, come here. Okay, it has opened the data frontier for you. So let's say you want to do we add data. We add, let's say 17, 12, 24, 25, and 30, 38. Okay. Then we call it okay. We want to change the name and call this one age. On the right side, you go there. Yeah, age has come. In stata, you have to put in the what do you call it, the data, your values, before you talk about the name. The name is changed at the right side here. So you put in, you can also highlight it, then you give it a name here. When you highlight it, you can say, let's say age and income. Okay. Oh. All right. It's not working now. Let me put in some amount. Say, let's say 100 rand. Okay. So you go here. You can change the name and put income. Yes, so income has come. So 100, 120, let's say 50. This apply changes to, let's say 50. Then okay, then 35. All right. So this is how you put data into let me do a sex thing and oh, what was the name? Oh, no. Okay. One for male, 0 for female. Okay. Okay, so we have one here. Let me go and say this one is sex or gender. I have to highlight the column before it comes. Sex. Okay. Then I have sex now. So I want to go and change the value label for sex. I highlight this column. I come here. I write the label, sex of respondent. Then I go to value label. and it opens a dialog for me here. I say that, okay, create label, and here I say the name is sex. So 0 is for female, and you add, 0 is for female, then 1 is for male. Then you add, okay. So you close this one. It won't change automatically. You go here and you click value label. You click sex. Then you go to this value label, show labels. Okay, I think we can go here too. This thing has to show sex and I don't know why my sex is not changing from male to female in the values. I think, yeah, they should work. All right, so this thing is disturbing me today, but no problem. Yeah, it has now come. So everything has changed to male and female. One thing you are supposed to check well is the labels. So you can also do a label for income. You do a label for all of them. You highlight income and you say income is equal to amount received per month. Okay, so does it label amount per month? Oh, I wrote it at the wrong side. Right, so when you type and enter, it will change this one to amount per month. So this is Stata and how data is entered in Stata. After that, everything you want to see about your data is here. Unless you want to run analysis, then you go back to this side and run any analysis that you think you want to do. And in Stata, everything you do, there's a record. So it will record all the changes I've made. The label variable for sex is sex of respondent. 1 is female, 1 is male. You can type describe. Let's say income. And it will show you amount per month. So this one will show on any computer that you send this data to. So that is how your data labels and your information about your data will go anywhere. So after that, you can go back to browse or data editor and save your data in any form. You can save as. But the difference is that with Stata, it doesn't give you any types. Only Stata that you can save in. You can save in. But you have a way out. If you go and say that export, then fine. With export, it can give you. Oh. Let me see. You can export your data from this file to another session. Okay, fine. You can export to Excel spreadsheet, SAS, DBase, CSV. I think CSV, SPSS can understand CSV, and R2 can use CSV. So you save it in CSV, you can export it straight to R, and you are gone. So these are two key softwares that you can use to enter your data when you have a small project to do. Other than that, when there's a big project or a research work that has a broad funding, you can apply Google Forms, you can use ODK, you can use any other means to capture your data. It will go straight to an Excel file and you are gone. This one is to help you understand how to create a questionnaire and what to make meaning out of a questionnaire. And if you have a small project you want to do to solve a problem in your local area without much funding, you can just create table your data with SPSS or this one. Let's go to Excel, the last one of the statistical packages that we have. Excel, come here. Excel. Sorry, if you send me a chat, because I'm presenting, I don't see. Okay, fine. I think there's nothing here. Excel, where are you? I hope this machine doesn't freeze today. There are a lot of things happening there. Oh, Excel is okay. Excel is in. All right, so with this my Excel. Okay, let me add a new sheet so we see what we can do. Okay, with Excel, the first row here is most often used as the variable name. So you can have age, then you can have sex, and you can have, let's say, income as we did today. It's very easy to enter data in Excel than any other thing. For entry, Excel is flexible for whatever you want to enter into it. As age, sex, you say 101. Okay, so 00. All right, so income can be 140, 30, 350. Let's say 100. Let's say 200. All right, but the most interesting thing here is that you can copy any data from Excel and paste it in SPSS or Stata. You have no problem with them. You can copy this thing I have here. Let me try. Let me copy. I can go and paste it. Unlike SPSS and the rest, Excel can give you a source where you can paste anywhere you want. If you want to clear data from Stata, you just type clear and enter. The whole thing is gone. So I go back to the data view and I paste whatever I brought. So if you want to paste, it will ask you a question. Do you want the first to be variable name? You say yes. So what I just did in Excel, I copy it and I paste it in Stata. No problem at all. No problem. And everything has come. Excel is now giving me a label. The same thing they use for the names, it is giving me the same thing as the labels for the variables. But one thing is that with Excel, it's difficult for you to create the variable labels, variable what do you call it? Values. Let's say if you want to say this is female or male in Excel, it is done, but those with advanced knowledge in Excel, they can do these things easy. And Excel is so dynamic that you can do a lot of things. You can just create a formula. When you put in figures, it will just calculate something else for you. So that's the power of Excel here. Excel 2 does a lot of calculations. And if you want to do simple computation in Excel, you just put equal to, you say this is B, this is B1, this is 2. So the intersection of B and 2 is B2. So you can say B2 plus 4. Okay. And in this particular cell, you press enter, it is 5. So any formula that you put in here, you put equal to, just know the cell name. Okay, fine. The first thing we do, some of the things we do is to find, what do you call it? Variance. Okay. So let's say we come here, we say at average. So we select this whole thing. The things at average. At average. Then you come to select this whole. How are you disturbing?
Prince.
Okay. Yes, please.
Yes, you need to, after you typed average, need to have a bracket, and then you can
Yeah. Oh, sorry. Yeah. So, okay. Thank you very much. Yeah. You close the brackets, then okay, fine, 4.2. So you want to find the variance, so we create variance var1. So what you do is that this is A2, okay? So you create equal to, please always know where you want your answer to be. If you want your answer to be somewhere, you just go there and you say, okay, A2 minus A6, then enter. So this is the variance. 22 minus 45 will give you this. So Excel is more formula thing. If you don't know the formulas and what to expect in Excel, it becomes difficult. If you want to sum all these things, okay, you just highlight everything. You go here, sum, and it will give you the number. Simple as that. You can also take this one and put it somewhere. Highlight everything here. Just tap on sum, and it will give you the total. Excel is very, very, very. No wonder Prof said that God rested on the 7th day, woke up a bit and created Excel and ran away and go and sleep again. So this is Excel and its miniature things that it does. The one I'm very good at is Stata. So for my bias sake, I'm going to do a lot of things with Stata for about 10 minutes. And all these things I do with Stata, we are expected that when we start R, you are supposed to know them. I'm not going to teach you, but you're supposed to know them in R. So I'll find a data source in one of my Stata outputs and we'll go from there. All right, so which one are we to use? Okay, I'll use this one. Okay, so I'll call in a data, open any data that I have on my machine. All right, so let me clear here. Then I import data. I open any data source. Okay. All right. Okay. I think I have one data here. All right, so let's go and see what I have there. I have household data, age, marital status, experience, a lot of things happening here. Average price per fowl. I think this is a poultry farm data, but because I'm not going to do a lot of things technically, I'm just doing a descriptive summary. So we go to here, and let's say you want to know something about the data. So you write describe any of the things you want. Let's say age. If you don't spell it well, it gives you a problem. Okay, let's sum age first. Okay, so sum of age will give you number of observation is 98, the minimum age is 70, maximum age is 90, the mean age is 44, then standard deviation is 11. Okay, and these things, let's say let's look at sum of average price on the market. Okay, so the mean price is $38 for rent or whatever. Minimum is 0.1, maximum is 0.6, standard deviation is given. But for regression purposes, if you want to run a regression, one of the key things you want to look at is the your graphics and how your data is behaving. We want all data to be having a normal distribution. So you have box plots or histogram. Let's use a histogram on average price and see what to. Okay, so the average price. Okay. All right. And we want to show add normal density plots. Okay. If you submit, it will run. You see this thing running here. It will give us a graph to show whether our variable is yes. So this is supposed to behave like a normal distribution. This is only one variable in the whole data, and it is showing something like a normal distribution, but the variation isn't that normal. You see, all these here are outliers. All these here are outliers. So it has a potential of, let's say, biasing our outputs, because if your data is not normally distributed, you have wide variations. The mean, like let's say this is 3 point something here, 3.5 or so, and most of the things are below 1. So if you want to find the mean for this, you know, something 3 point, let's say 3.2, okay, 3.2, oh yeah, 3.2, the difference between 3.2 and all the things here will make the mean a bit bigger than it's supposed to have been. Supposing this one was down like this, then we will even accept that it's a normal distribution. But because of this, and if you don't do plots like this, box plot or histogram plots, you'll never know. You estimate your model and you don't have any of them significant. And it's like, why is my model not significant? Some of them is because of your variable that you took. Some of them are not really behaving as they are supposed to behave. So this is one way to do that. Let's go back. We can also do a box plot, and we don't have much time, but I'll try to see what I graphs. We can do a box plot, okay. And our variable is still price, average price of fowl. Okay, so we click submit. Okay, so interpretation of box plots. When your box here is almost, I think, let me ask first, if you have seen any published paper with this thing. Sometimes they are smaller because of the paper is small. This thing is called a box plot. If you don't know, it's called a box plot. If you have this box, the shaded area has to lie definitely between, like it should come up small. So it is the space here and the space down here, they are supposed to be the same, equal. If the space here and the one here are equal, it means that your data is, your particular variable is having a normal distribution. Look at what we have here. The space down up here from this line to this line is bigger than the one down here. It means that there's a problem with this particular variable. Okay, so you have this whole thing not being so normally distributed. Okay, so one way to check for normal distribution in a variable is to linearize or to log the variable. So you can say generate. These things I'm writing is the code. In SL and in SPSS, you don't write a lot of these things, but in Stata and R, you write. So you generate log P, let's say log P, which is equal to log of, you open a bracket and you put this variable in there. You close the bracket. You have log of this. So it will be created down here. Log P is created here. Okay, so let's go back and do a box plot or a histogram plot and use log of P and see what we get there. So log P has appeared here. So we say that density plot, you should just put density plots. Then let's see. All right. We log the variable here and look at what we are having. Okay. Now the space here and the space here, try to show up something. Who can tell me what is happening now? The earlier on graph that has shorter, whatever thing, what do you call it? Shorter bars. Now you see the bars are a bit longer than that it was. Can anybody confirm to me that the bars here are longer than those that was in the before one? In the before one, none of them even came close to 3. Now you are seeing them rising. It means that the gap between the mean and the other variable, the other figures are closing up. So it approaches a better normal distribution than the earlier one. Okay, so whenever you have a variable showing a lot of inconsistency with respect to normal distribution, just linear log the variable, and it will give you something better than you were having earlier on. All right, I've spoken a lot. Let me drink water for 2 minutes and I'll come for questions. Thank you. I'm coming. All right, I'm back. Any questions so we can get the session closed? All right, any question, please? How to put data into SPSS, into SL, and into Stata. Next week, we swing straight to coding in R. Anybody with any question? I don't know if I open R, my thing will not freeze because I have about 5 softwares open right now. Statistical softwares are big, they take memory. So, but if there's no question, I can open R and do a brief introduction, then we close. Any question?
I think it will be very helpful if we can move to R.
Okay, fine.
If there are no any questions, yeah.
Okay, if there's no
Thanks
question,
a lot.
I'll open. Let me close some of the softwares. In fact, I may freeze my machine.
Okay.
Yeah. Okay, so I'm opening R. Anyway, I have eViews, but I'm not good at eViews, so sorry those who know eViews. Sorry I didn't touch on eViews. I have eViews, but I haven't learned it. In fact, I can't learn everything, so I have to give myself some space.
Yeah, absolutely. But I mean, R is the way to go now, so that's why you want to learn it.
Oh, R is the way to go, but Stata is very, 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 very useful. Everything Stata does, R does.
Yeah, I like Stata a lot as well. I can use Stata as well, but now, you know, most organizations, most universities, they're looking at somebody who knows R because it's free.
Yeah, they don't want to spend money. Yeah.
Yeah.
Okay, my R is gradually walking in majestically today. Let's bear in mind that there are some of us who hasn't done anything econometrics before. They haven't done anything statistics. They haven't done anything estimations. So please, those who know to do, pardon me, forgive me for probably wasting your time, if there's a better way to use. Some of us, we don't know anything about what we are doing, so allow so that we can get it. And econometrics is said that once we start econometrics proper, and you don't know the basis, how data is formed, what you only know that data is there and you want to use, sometimes you might not even run faster. In fact, what we are doing now with Prof is just bit like kindergarten econometrics. And please, if you want to do econometrics and do it better, understand probability. I beg you in the name of God. No probability theory, because the distributions and the models that you are going to use, all of them is probability. Random variables, probability distribution functions, whatever. When you have, what do you call it? Ordered logit, ordered probit, all those things, you have to know how picking some object from a group of things with replacement, without replacement, all those things. In fact, all those things. And I don't know if you get time to do everything, but econometrics is a bit involving, very, very much involving. All right, so this is R for you. Today, I'm not sure I'm going to type anything serious in R. I'm just introducing R. For anybody who doesn't know R, this is R. It has nothing like SPSS. It has nothing like Stata. It has nothing like whatever you know before. It's a new thing in itself. It has its own characteristics. So most of the thing that you do, this area is called the script area, where you write your codes. Everything you write here and you put enter, another number will come. Enter, another number will come. Enter, another number will come. So the numbers will help you trace what you have done. Okay. The numbers will only help you trace what you have done. So in next week lecture, you know, I will refer to maybe line 5, line 10, line 25, and you see a code there. You can replicate the code. You can type the same code in your machine, and you see changes there. Okay, I will tell you what these are later. So this is your R script where you write your codes, and this is your console, where whatever you do here, okay, comes here, or whatever you do here, whatever you do at console level also registered at the R script level. But if you have anything here in the script side, you can highlight it and go and click run, and it will appear. Results will come. Some of the results, most of the results will come to your console side. All your results will come to your console side. So let's say, let me do something small. Let's say 4 plus 5. Then I click enter. Oh, what did you do? 4 plus 5. Okay. So if you do 4 plus 5 and say run. Okay, so 4 plus 5. I just did 4 plus 5. And I run 4 plus 5. And I have 9 here. So most of the results you do here, all the codes that you write here, they will appear in your console level. And it is just like any English language. R is like writing English language. Everything there has a bit of a meaning with the language English, but it's a bit technical. So we'll start and see. This space you see here, when you have data, the one on your right side here, this one, when you have data or you have anything that you are using to, if you have data here, you will use the R script area to manipulate the data. So all your data will come to this side. Every data you have will come to this side. And this side here that you see, the screen is divided into 4. We have the left, we have the script and the console. And the right side, we have the environment area, and we have the library or plot or packages area. Here, 3 things happen here. If you have any graph or plots, it will show in this lower corner here. And you have packages, it will show here. Packages, R is a language, okay? R is something written that when you click the run, a piece of information put together that when you highlight and run it, it will show you results here. But some of the things that you are going to use, they are pre-programmed. Someone sat down and wrote the program. So that program will help you to make what you want to make very simple. Those programs are called packages, okay? Packages. And you need them to do a lot of things in R. Some of the packages are already built in the R. When you install it, you have some packages in there. They are called the basic packages. Basic packages. And some of them too, you have to install them. They are called the contributed packages. Individuals sat and they designed them and they added it to R. So some of the packages are SchemR. You see here on the left side. SchemR is a package, Tidyverse is a package, ReadSL is a package, and the flight NYC flight is a data inbuilt in R already. It's already in R. Some of the packages are Tidyverse, what do you call it? Shiny, a lot. In fact, there are thousands and millions of packages. ggplot for any other thing. You know, if you want to read SL, if you want to import SL data, is it Wazili or Paul Smith or one of them asked me if you want to bring data to SL. Some of these things, if you want to bring SL data to R, you have to install the package called ReadSL. ReadSL will allow you to read any data from Excel. ReadSL is a package that allows you to do that. In fact, R is said that anything you want to do, I may say it has its own package. Even though some of the packages are inbuilt, but other individuals are creating, every day they are creating a new package that can make work a bit easier and faster. So you have many individuals contributing to the what do you call it, establishment of R. All right. So if you want to make sure you do anything with SL data, you highlight this thing and you click run. Then you library it. It means that now SL, this library thing, this library that is this library, the name library, means that you have brought this whole ReadSL into memory, like you have activated it to work right now. If it is here and you haven't library it or run it, it is there, all right, but it will not work. Unless you highlight it and run it, then it comes down here to show that it's in memory. It can now start working right now. Okay, so R is a bit technical. In fact, if I don't say it's technical, then I'm lying to you. It's a big technical thing, but we will start something next week, Wednesday, and we'll do something better with it. Now, everything that you do here, you have these things. You see these things here. They are scripts. You can save them. These are some things that I've done earlier on before. You can save any of them and use it in another date. Okay. So when you have this, okay, any one or you type that will show here. It is the one that all these tools here are working for. So now that I've opened Personal Study R, I can go to File and save this particular thing. Then I can come to PE Practice and I can also save it. So anytime we are doing R something and you are in your house and you run your codes, don't forget to save it. You save it, you can retrieve it and use it another day, or you can even refer to it when nobody is there so you can work with it. All right, so your plots and your packages, they show up here, and the packages, they are online. Okay, you can click on them and search. You can let me say if I can search for one package called Shiny. Let's see, it's Shiny here. Okay, Shiny is not here. It's not here. Let me say, you know, the scheme R that I have, the scheme R here is showing here. String is showing here. When you want to deal with sentences, you analyze sentences, you can use string R to do that. Anything that you want to do, there's a package for that. Okay, so let me see if Pacman is also here. Pacman. I'm online, so sometimes you connect and the R is already online and it can check online for you. All right. Okay. Let's not waste time, but we'll do a lot of them. So many analysis that you do, you may use any of the packages to do. But before that, next week I'll be teaching you what integers are, what R understands particular languages. So if you don't use the language, you may find something different as your resource. So you have to know what integers are, what numbers are, what everything about these things you know. But basically, everything you do here appears here at the console, and your data comes to the right side, and your plots and everything come to the lower right corner of your interface. I think this is briefly what I want to do about R. We have already done a lot of things, and I don't want to complicate it now. So if you have YouTube, just go and there are a lot of videos about what to do with R. Please engage YouTube and learn a lot of them, because we don't have enough time. When it is 2 hours, we will not have enough time to do, and we have a lot to do. I'm telling you, we have a lot to do. We have a lot to do. Models and their complications. Sometimes even myself, some of the models, you read them and you don't know whether they are Chinese or whatever. Some are difficult. So we may not waste much time with basics in R. All right, thank you. And if there's any question, I think it's already 5 or something. If there's any question, let's do it. And next week we start R proper. Because R is our main subject, we will spend time there. That's why today I'm not worrying. The rest, we are not doing them. So I'm just showing you what it is. But R is our main target next week.
Thank you, Prince. There's just one administrative question. Is there a formal study guide for this module? You've posted the references, but is there a study guide?
We're working on that. I thank you for that question. I forwarded the study guide to Prof. Dr. Gaj, and due to his busy schedules, he hasn't completed yet. But very soon, I promise you, by next week, we will post the study guide on ClickUp. So when you go to ClickUp, you can find it. I'll insist and push him so we finish it earlier and we can give it out.
Thank you.
Yeah, for R, there's a book you may download to study. Let me see. It's called I think my screen is still shared, right? Is my screen shared?
Yes, it is.
Yeah, let me show you this book. You can find this book and read it. It's very helpful. It's written by, I think, let me go back a bit. R for Data Science. That's the book, R for Data Science. You can search it online and read. Okay. It's written by Hadley Wickham and Garrett Grolmond. Yeah. I've used it and it's helpful. R for Data Science. I hope everybody gets it. Hello.
Yes, thank you. We will search
Yeah.
for it.
Yeah, search for the book and it will help you. But the most helpful thing is the YouTube videos, because some of the things when they write them and they are not showing them, you don't see whatever it is. So you can get to YouTube and find videos that will help you very much with R. Okay, I think I'm open up for any other question. If there's no other question, then we may call it a day. I've been speaking for quite a long time. All right. Anybody with any
I
question?
just wanted to ask, which version of R are you using?
R? Do I even have a version? You know, R is a free source something. I downloaded, probably by the time I downloaded, I think the current one that is there, I don't really have knowledge about the whatever. I don't have knowledge about the version. If it's about SPSS or Stata, then fine, I can tell you Stata. I'm using Stata 16, and SPSS, I think I'm using the 22, 16.02. All of them are 16, but for R, I don't know. I hope the class have been helpful today, those who don't know anything about econometrics and data. Tell me something if you enjoyed what we did, and probably we close. Anybody saying anything? Anybody saying anything about today's lecture? Was it good? Was it fine? Did you get what you wanted? Anything you think I should improve next time? Tell me something. Everybody is just leaving like that. Wow.
Yeah, it was good. Thank you very much.
Okay. Thank you, Dharma. All right. If there's no question, thank you for coming to class. Thank you very much for your time. See you next week, Wednesday, and Monday. God be with you. Bye.
Thanks, Prince.